Go ahead.
Okay. No. My God. Share screen. Hiding. Okay. I already got conveyor belts open in VS Code. I just do not remember if I need to do the git pull command equivalent using mob.
Yes. Mob start
Mob start
7
7.
and mob
Okay.
timer open.
Mob starts. Okay.
Is their server down?
Okay. No, it's not down. It just took a while.
Okay.
Mob starts 7 and show the timer. I just a mob timer open is like that.
Yes.
See it? Oh, it's here. I'll just put it over here. So it.
Huh.
Okay. Done.
Yes, good. Well, we had some progress.
Mm-hmm.
And
Yeah,
okay.
I remember that you show me a link to a pull request.
That's figured out by now.
Oh,
I got
okay.
an answer there, so it was a good answer. Now there's a different subquest. We are now at a point where we want to implement the spawning of a browser.
Mm-hmm.
For that, we have the browser spawn driver.
Okay, here.
Yes. It already receives a browser spawn driver command from the app.
Mm-hmm.
Now we have to figure, since the library that we are going to use for spawning and controlling the browser, it's called Chromium Oxide.
Mm-hmm.
It is async. It's an async API. Now, we're not, we are in an async context, but we are in blocking code. We are in an async context because we are currently running, we're using Tokyo main, the macro, attribute macro on the main function. So that makes our entire context, the entire execution of the app, of the program, is async. Is it within the Tokyo async runtime? But there isn't a single async function here. Not in our code. not in our
Oh,
code.
yeah. Yeah,
But
the drivers, they are sync internally. Sort of. Okay.
yes, well, it's all blocking code.
Yes.
But the reason that we are in an async context and we have a runtime is that RX Rust requires that.
Mm-hmm.
It is implemented using Tokio specifically.
Mm-hmm.
Even more specifically, a certain flavor of the Tokio async runtime. There are two stable flavors and there's one unstable flavor, and for some reason RX Rust uses the unstable flavor. So what you're seeing here commented out is like some version of what we need to do.
Mm-hmm.
Because we
But
do
this is
need to
not.
call await somewhere. We do need to have an async block somewhere, and we do need to, but we need to spawn it blocking.
Mm-hmm.
We need to spawn an async block that'll do the browser things like browser init await that keyword.
Mm-hmm.
And there's a utility in Tokio that is there. I think there are two that might be. One of them is probably our solution. It's called block on, and there's another one, spawn blocking. I'm not yet sure which one. I think it's probably one of them. To use them, we need to obtain a handle to the runtime. If you open the Tokio docs, we should be able to figure it out.
Tokio docs. Tokio docs.
Good. Search block _on. And you can see that there are several.
In our context, we are using block on browser. Let me.
I don't think the answer that you're looking for what the answer to the question is in our code.
Okay, so it's one of them.
It may be. We have to read the docs enough to figure it out.
Let me see this first one.
Mob.
Runs the features to completion token runtime. This doing damage deployment.
Did you get the notification?
No, because I am .serp. But I got it, yes. Mob next. So, stop sharing.
Cargo doc open P Tokio. Block on. Not all crates. Tokio. The reason I have fewer results, is because I built the docs locally.
Yeah.
And I bet it's because some features are disabled here.
Mm-hmm.
Some items can rely on features, therefore.
Mm-hmm.
That actually helps us because it omits irrelevant things.
Mm-hmm.
So we have to figure out this one is, if we take a look at the main, see this Tokyo main flavor local?
Mm-hmm. Yes.
This is the unstable
Flavor.
flavor that I was referring to. So
Mm.
I don't know yet. This one is flavor specific, like flavor specific, it seems, and these two are not. And this is the represents a runtime itself, and this is a handle to a runtime.
Yes.
And I don't
Mm.
know the difference or how they are used. And I don't know whether we should, I don't know whether we must use this because we're using the local flavor. I don't know the answer to these questions yet. I'm just randomly starting with this one.
Mm-hmm.
So a local set is a set of tasks which are executed on the same thread. In some cases, it is necessary to run one or more futures that do not implement send and thus are unsafe to send between threads. In these cases, a local task set may be used. Schedule one or more non-send futures to run together on the same thread. For example, blah, blah, blah.
Mm-hmm.
Use with run until. So this is the beginning of that. And now we can go back and
Mm-hmm.
read the runtime block on. Runs a future to completion on the Tokyo runtime. This is the runtime's entry
Entry point.
point. That makes sense. I think this is probably what Tokyo main attribute macro desugars into, like the construction of a runtime and then like runtime block on the main function. In fact, we can
Yes. Yes.
does it make sense?
Yes, that actually makes sense.
Okay. And I'm not, so there's a command, search for commands, something like expand there. No? Oh. What?
I
Pan? I don't know why it doesn't expand.
mm,
Macro.
in my Rust analyzer is complaining about an error.
It's a warning.
Okay,
Oh,
okay.
if we'll get back to you when your pilot will figure it out. I think I
Okay.
know what it is. Rust analyzer expand macro expand Rust LSP expand macro. Okay. So see this?
Yes, it
On the left
uses
is,
block on. Yes.
and so this is the truth about it. See, this is recursive expansion of the main macro. Here's
Mm-hmm.
our body, our real body, what we wrote, right?
Mm-hmm.
This is the main function body that we wrote, and then that body equals something. Put it in a future. Something like this is where we get a warning or your
Yes.
error.
Yes.
This is use runtime builder, build new current thread, enable all
Yes.
build local. So actually, it seems that local is a subvariant of current thread. Default, and then block on body.
Yes. Yes, but it makes sense because it needs to block the main thread. I have a question. Do you know if Tokyo is similar to, I don't know, Python threads when the program, the main program keeps running while there is another running thread that's at the same time, something like that?
It can. It
Interesting.
can be, but it's not like inherently so. Tokyo can be definitely used to do parallel, multiple threads. It can be configured to do used to do parallelism implicitly. It can be used to do it explicitly. It's flexible. It's powerful.
Interesting.
What did I make a change here? What is this? I don't know what this is, but I'll next it.
Okay, so it's my turn.
Yes.
Okay, screen. Share. So Mobstar 7. Yes.
You need to do dir env reload, and then start your editor from that shell.
Oh, like close everything. Okay, so I'll close.
Dir env reload.
Okay. Dev env reload like this. Okay. Dir env. Wait a minute. Dir env. Okay.
Now try building the Tokyo docs and.
What's it's cargo?
Cargo doc. Flag open. Flag P. Tokyo.
I'll just wait for the result analyzer to finish.
It will wait for you.
Oh, really? Okay. Building. Okay, let me see if it open. No, this is not. It tried to open. Let me see it. Oh, it's here. Okay. Great Toko. We were searching for block 1, right?
Yes. So why don't we start with the runtime block on?
Okay, runtime block on. Okay. This is the runtime's entry points.
Assuming this might work, the question is not what this does, because I think I know what block on does. The question is more like, can we obtain a runtime struct without constructing a new one? Because one exists somewhere in the background.
Yes.
So the answer to that will be in the same page, on the same page that we just looked at.
Yes.
Not our code, the runtime documentation.
No, it's not here. It's
See, but that was it.
it's
What?
here. It's here.
Okay. Yep,
Okay.
that's the local one. Good.
Yes.
So the question is, because block on is called on runtime. See, it's a method on runtime. It takes ref self.
Yes.
The question is, can we obtain such a
Using
struct
structure.
without
Yes.
constructing it? Can we obtain?
Yes.
And I think last time I checked, I figured out that no, it's not possible. Do you see the methods on this? You see their names on the left in the table of contents. Yes, all of these.
Yeah, but honestly, block on, enter, handle, matrix, new, shutdown backgrounds. Yeah, but it seems to be something like a little bit more lower level compared to the other APIs. Like, I'm not sure if we should be calling these APIs. Because I think the runtime is something that is managed by Tokyo itself. I'm not sure.
Well, we need to call block on.
Yes.
Probably either on the runtime or on handle.
Mm-hmm.
Let's read this part about sharing.
Okay. There are several ways to establish shared access to a Tokyo runtime. Using an Arc runtime, using a handle, entering the runtime context. Using an Arc runtime or handle allows you to do various things with the runtime with spawning new tasks or entering the runtime context. Both types can be cloned to create a new handle that allow access to the same run. That's interesting. To the same runtime. By passing clones into different tasks or threads, you will be able to access the runtime from those tasks or threads. The difference between Arc runtime and handle is that Arc will prevent the runtime from shutting down, whereas a handle does not prevent that. Okay. This is because shutdown of the runtime happens when the destructor of the runtime object runs.
Makes sense.
Calls to shutdown background hider is require exclusive ownership of the runtime time when using blah 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 blah. The runtime context is entered using runtime enter and handle enter methods, which use a thread local variable to start the current time, whatever, blah 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 blah. We use the runtime with your context. Okay. Oh,
Mob. Okay.
mob next. But I think stop sharing.
By the way, you don't have to stop sharing.
I know.
Am I sharing? Good.
Yes.
So this is runtime. We're reading sharing. The runtime context is entered using enter, runtime enter or handle enter methods, which use a thread local variable to store the current runtime. Whenever you are inside the runtime context, methods such as Tokyo spawn will use the runtime whose context you are inside. Okay. And runtime can be, you said something like, we shouldn't be using this, we should be using Tokyo main, but it's well, you can see from this, from sharing, that it's okay to use this, especially if you
Yes.
need access to the runtime
Yes.
across
Yes.
threads. And I think in our case is another use case where we do need, because the alternative is that that our entire call stack from main to the function in which we need to call await is async.
Yes.
Async functions. But
Yes.
or async blocks. But we can't do that because we have a library in the way.
Yes.
We're passing the subscribe call and the browser spawn. So there's a subscribe. There's a subscribe here, and this is where we need to do the await, and we can't give this thing an async function. It doesn't take an async function, and there is no alternative that does take. There is only this blocking code. So we are in blocking code. We need, the only way to run some async code is to say, okay, we are in a runtime context. We're just not in a async function. So we need to obtain a runtime handle and somehow call block on. And this is like the beginning attempt of it when we ran out of time. So what we try to do here is handle current. Okay. So
yes.
Okay, so handle current returns a handle view over the currently running runtime. See, it doesn't take arguments. It just returns a handle. And it panics if called outside the context of a Tokio runtime. That means that you must call this on one of the threads being run by the runtime. Or from a thread with an active enter guard. Calling this from within a thread created by std thread spawn, for example, will cause a panic unless that thread has an active enter guard. So we said we will, and there's I think this is a good example because it shows that you get the current handle. Let's say we are inside an async block. Get the current handle. You can do spawn of an async thing. So this spawns a task. So this is kind of a proof that you are inside an async context.
Yes.
Also, you can thread spawn.
Okay. Okay. Yes. Yes.
This is kind of omitted. Where is this? I think this is std thread spawn. Notice that the handle is created outside of this thread and then moved in. This handle is created here and then moved here, and we can do spawn, and this is async again. So this is not quite our situation because we're not inside a spawn thread.
Yes. We are inside yes.
So what we're doing here is creating an enter guard.
Yes. Okay.
So let's say we have obtained one, and then we can do call enter. Enter is the runtime context. This allows you to construct types that must have an executor available on creation, such as sleep or TCP stream. It will also allow you to call methods such as Tokio spawn and handle current without panicking. Panics when calling handle enter multiple times. The return guards must be dropped in the reverse order they were acquired. Failure to do so result in a panic and possible memory leaks. It kind of makes sense to me. So here's the guard, and here you can do. So now you just created the runtime. You're not in a runtime, right?
Yes.
Here you synchronously entered the runtime. You have a guard, and you can do this Tokio spawn thing. So I'm thinking we can block on this handles runs a future to completion on this handle's associated runtime. This runs the given future on the current thread, blocking until it is complete, and yielding its resolved result. Any tasks or timers which the future spawns internally will be executed on the runtime. When this is used on a current thread runtime, which ours probably is a flavor, like subflavor of, only the runtime block-on method can drive the I/O and timer drivers, but the handle block-on method cannot drive them. This means that when using this method on a current thread runtime, anything that relies on I/O or timers will not work unless there is another thread currently calling runtime block-on the same runtime. So maybe this means we have to obtain the runtime itself and not a handle and call runtime block-on?
Yes. That's a little bit confusing, but okay. I'll accept that. But yes.
Well, we have an attempt pretty much set up, so I think we should probably try it.
Okay, so I'll just grab
Also,
a
I'd like to
little bit.
read the rest of the panics there.
Yes, I'll just grab a little bit more coffee. Okay, let's see. Share screen. Share. Let me see. Okay. So, and then mob start 7. Okay. So,
That was handle block on.
okay, handle block on. Okay. And this associate this given the feature block to content. Okay. Okay, if the runtime has been shutting down, or dropping. Okay, panics. This function will panic if any of the following conditions are met. The provided future panics. It's called from within an asynchronous context, such as inside runtime block-on, handle block-on, or from a function annotated with Tokyo Man.
Oops.
Hmm?
Oops, that's our case. We are currently annotated with Tokyo main.
Yes.
So you can't do both Tokyo main and block on.
Yeah, you cannot attempt a feature.
Maybe the guard is an exception. Like enter is an exception to that.
Yeah.
Can we see handle enter? Because we don't have
handle
currently we
enter?
have only
Okay.
a. So we read this, right?
Yes.
Yeah, I think this is not sound, but I'm
Yeah.
not sure what is sound. Okay.
Yes.
So
Just let me
definitely not block on, right? Like this is not like if we were to do block on, I think we can do this, but then we would need to remove the main.
Yeah.
And we would need to spawn a runtime and then using an probably an RC, clone the runtime and pass it on to each driver that needs it. Currently, only the browser spawn driver needs it.
Yeah. I think we can give a look to local set block on just to see if that's not the solution to our problem. Let's see. Runs a feature to completion on the provided runtime, driving any local feature spawned in the stat set on the current thread. This runs the given feature on the runtime block until it's complete and yielding its resolved result. Any tasks or
Just skip
timers.
to the panics.
Okay, this function panics if the executor is at capacity, if the provided feature panics, or if called within an asynchronous execution context. That's also our case, right?
Yeah. We're always in an asynchronous execution context because we're using Tokyo main. The thing is, we don't need Tokyo main. Like we need the runtime only in specific places, not in our entire app.
Oh, that's interesting. Okay, I have another question. Let me think about it. This browser it needs a way to map all of the. Okay, this is I think this is an asynchronous. Let me think. Isn't isn't there a way of running this function synchronously? I don't think so, but
No,
mm,
that is the utility to do that. You must use await, or you must use some Tokyo utility that uses the runtime to walk on
yeah.
it,
Mm,
to execute it.
yeah.
So what I think we should do is basically what the Tokyo main itself does, what it expands to. We should do that ourselves and then pass the runtime where it's needed.
Yeah, so we can, yes. So how I how I undo this macro?
What are you looking for to expand?
The Tokyo Man.
You want to expand it, or do you
Yes,
want to?
is I don't know.
What I did earlier is expand, like to see what this expands into.
Yes, expand. Yes, but just let me think for a little bit.
Tech bros are injecting themselves with gray market chemicals to get hotter.
Sorry.
Let me think. I don't know. This context is not a sync; it's a sync context, right?
It's depends. Is there an async? You can't tell by reading any code. You can tell by looking up the stack.
Okay. Hmm.
Our async our main.
It
Uh,
is async. Yes.
It's it's async and it's using a Tokyo
Next.
main.
Yes.
So
Wait a minute. I think we should try to use. I think. I think we should try. Let me think about it. Yes, but wait a minute. Because all of the block-on methods they will panic if they are called from from within an asynchronous execute. Let me think.
Yep.
Block-on.
True.
Yes, but I'm looking to the example in BlockCon local set. Let me see to your
Ask me to look at an example.
Yes, could you look at the BlockCon method on the local set? Look at this example. For example, this one. For example, this will panic. It's doing exactly. I think it's almost exactly what we wanted to do.
You have a runtime. You have a local.
Look at this. This is the panicking example, but the next example, it's something that it will not panic.
So you're using the local to block on, and you're passing it a reference to the runtime.
Yes.
And inside of that, you're doing a spawn local, which uses the whatever current execution, current runtime. Inside, you can have a spawn blocking. The reason this, then you can do a wait here. The reason this is fine, the reason this is not okay, is because the local block on. This is fine. This is fine.
Yes.
This is fine. This doesn't seem to be fine.
Yes.
Oh, the difference is in this,
Method.
right? This versus that.
And has a dot await in the end. Yes.
This has a dot await because spawn blocking returns a future. This does not because it does not. And you can't do this conceivably. You can't do this, right? Because in order for this to block in place on some async stuff, it needs control of the runtime.
Yes.
But there can be only one. But a runtime is already being is already executing. I don't know what, a context or a stack or whatever it's executing. This doesn't seem sound to me. You can't block. You can't ask to block.
Yeah.
You can ask to block when you have control of the runtime, and there's already a reference given here of the runtime. It's like,
yes.
this await yields control back to the runtime. That's why it's okay.
Okay. Yes. Yes.
So I think
look at that. Another interesting thing. Now I just read that task BlockCon uses this, since this function internally calls runtime BlockCon.
Which BlockCon?
The runtime. It's the. I was reading on your screen. Okay, so
on my
so
screen?
the task. Yes. In the notes session.
Internally calls runtime BlockOn and drives futures local task set inside that call to BlockOn. Drives futures in the local task set inside that call to BlockOn. The local futures may not use in-place blocking. Yeah, that's pretty much my understanding. The blocking call is issued from a local task. Spawn blocking API may be used instead because it returns a future.
Yes. Hmm.
Yeah, so we cannot use main. We cannot use Tokyo main because we need explicit control of the runtime. That's what I'm thinking.
Yes, but using this, but we need to have explicit control of the runtime in this case.
I think so. In our case. In fact, yeah. Question is, will it work at all? Because the library is also relying on the library
Runtime.
also needs a runtime, right?
Yes.
So maybe the library can give us its runtime clone or something. We can share it with the library.
Yes.
I haven't read. I didn't read the docs for that. I think there might not be docs for that. Maybe reference documentation, but not
Okay.
prose. But that seems to be a relevant question, right?
Yes. I will steal your screen. Should I steal your screen share?
Yes.
Okay. So, yeah. Yes, it's creating a new runtime. Block on, enter handle, new. Creates a new runtime instance. Most applications will not need to call this function directly. Will attribute a more complex configuration, the runtime builder. Runtime new. Spawner.
You know, I think multiple runtimes can be used at the same time.
Yes, I think so. Yes. I think we can. Yeah, I think we can. No, we can create multiple runtimes, or we can also change. Avoid using the Tokyo main attribute, removing the macro.
Well, removing the macro and instantiating our own runtime and passing it around, but we'd also need to like enter it somewhere or because the subscribe calls, I don't know at what points in the API of RX Rust the context needs to be provided. It's probably when instantiating streams.
Yeah.
How about we take a look at RX Rust reference? You can do the same command you did.
Like this?
Yes. If we don't find something there, we can probably make multiple runtimes.
Okay. Zero cost. Okay. So Quick start filter. Okay.
So you see that local
Local.
that
This.
in the quick start example. You see that local from iter line 4.
Yes.
That's, I think local here is it stands for that this is a context, and from iter is a stream constructor that will create a stream that is with that context, or that is of that context.
Mm-hmm.
The design of RxRust is to be context flexible.
Mm-hmm.
And it's generic on a context. So it provides the local context and the shared context.
Mm-hmm.
We are using the local context. If you wanted a from iter in a shared context, you do shared from iter.
Mm-hmm.
Okay. Now, maybe the local type has some methods that we, for either for constructing it with a Tokio, passing some Tokio
Mm-hmm.
runtime RC, or maybe it can give us its RC, its runtime. Does that make sense to you?
Yes. Mm-hmm.
So it's a type alias.
Mm-hmm. Local T, local context T, local scheduler. Hmm. But it's a type of local context
Yes,
and
let's
local
click.
scheduler.
Let's follow
The
that.
rabbit hole. Local
Exactly.
context for single thread applications. See.
Scheduler.
Okay. Okay, it's here.
Mm-hmm. So internally, it uses spawn local whenever it wants to spawn a task.
Yes.
That's pretty much what's declared here.
Yes.
So we need to take a look at the documentation of spawn local
to see how it yes. Let me see it.
to see
Tokyo
what the
task.
constraints for that are, right?
Yes. Panics. If it's panics, if it's call outside the local set or local runtime, noted if it's used from local set, not local set, misuse some local front. Okay. Or local runtime on the current local runtime.
I'm not following. Can we read it
Go
carefully?
Back. This one?
Yes.
Okay. Function spawn local. There's a spawn ascend future on the current local set
Non-send.
or okay, no, okay, nonsense. Okay. On the current local set or local runtime. This is possible when either using one of these types explicitly or with Tokyo unstable by opting to use the local runtime flavor in low Tokyo main. I think this is our case. Yes. This types explicitly. The spawned future will run on the same thread that's called spawn local. The provided future will start running in the background
Can you-
immediately when
Can you explain what it means using one of these types explicitly? How do you use them explicitly?
let me
Oh,
see.
you use them earlier by entering them, by constructing one and entering
Yes.
one, right?
Yes.
So
Or
because I thought that RX Rust depends on the on
mob.
I don't know what the difference between local set or local runtime is, and I don't know what flavor local uses. Is it a local set or local runtime? I read it, but I don't remember.
yes.
But we're using one of them, right?
Yes, but I think we are not using them explicitly.
What was
because
it?
in the document,
Spawn local? This
yes,
one.
spawn local. Yes, from Tokyo Task. Yes, but I think we are because you can use either these types explicitly or you can use with Tokyo unstable by opting the local runtime flavor. Like
We're doing that, right? That's what we're doing.
yes, so I don't. So maybe these types are not being provided explicitly. That's my. I'm not sure about that.
What uses this is RX Rust,
Yes.
and it definitely doesn't do any of this, or that.
Mm-hmm.
This is user needs to do that, and RX Rust just expects to be able to call spawn local.
Mm-hmm.
So this is up to us, and currently we're doing this, right?
Mm-hmm.
And we don't know the difference between these two. Just keep that in mind for now.
Mm-hmm.
The spawn future will run on the same thread that called spawn local. Okay, that makes sense.
Mm-hmm.
The provided future will start running in the background immediately when spawn local is called, even if you don't await the return join handle. Okay.
Okay.
Panics. This function panics if called outside of these, which is not the case for us, right? If we remove
Yes.
this, it'll be the case.
Yes, exactly.
If we remove this, we have to make sure that RX Rust's call for this will be downstream from a stack where we've, did this. Note that if Tokyo spawn is used from within a local set, resulting new task will not be inside the local set. Okay, that makes sense. So you must use spawn local if you want to stay within the. Okay. Okay. So I wouldn't even know when. I wouldn't even know how to exactly when do I need. Okay. So back to RX Rust.
Mm-hmm.
I didn't build it. There. Local. It implements context, yada yada. but it's actually an alias to this. And this is a and that with the local scheduler. Okay, so let's see local context. With local context, you can get the inner, which is not what we're looking for. You can get the scheduler, so that's interesting. You can into shared it, which is not what we're looking for. Yes, templates, clone context, subscription. What does it mean to implement context? Context. It has associated types and methods from parts enter into lift, scheduler, swap, transform, wrap. Okay. That does not look like what we're looking for, but the scheduler seems to be exposed, right? From here as well. From local context. So if we get the scheduler, so the scheduler with this type alias is local scheduler. So let's say we are able to obtain the local scheduler. It implements scheduler, and that's it. It doesn't have any methods. So that might be the no. So I think I don't see an escape from having multiple runtimes. I don't see the API here. We could probably, you could probably make like this, my scheduler. But that seems like overkill.
Yes.
To implement a scheduler that is mostly the same as local scheduler, but somehow can, past the.
I have another question. Let me think about it. Couldn't we try to use, I don't know, because a part of me, I think it would be interesting to test. Because we are trying to we are looking for a lot of alternatives to execute our async function on our application to launch the browser. But I think I'm almost considering that maybe we could try to use the task local set block on just to try it if it works or not.
Will never work because we're inside, everything is starting from a Tokyo main.
Yes. But
so we're in an async execution context.
Yes.
And that's it. It panics when called within an async execution context. That's it.
Yes, but can we see it panicking?
Sure. You want to see it panic? Go ahead.
Let me see. Process spawn, browser spawn. So this however will not panic. I am on local set block cons. I will just copy paste it on the and just comment this just to see it happens in stream. So what we would need, token runtime. Oh, that's the problem. We don't have access to our runtime. That's the dependency.
We do. We do. We can call current, right? Line 41.
41. Okay. Okay, yes, you have runtime handle, but it's a handle. It's not a runtime.
It's equivalent
Okay,
for
okay,
our purpose because you can call block on it.
okay, tá. Okay, let me see if. So let's create this. Let's local. So block one, I think. Let's join spawn local. So this does we need the result, right? Yes, we need it.
Yes.
So let me think about it. Okay. So should be something. Join handle, result, handle spawn, browser image. Okay, so we need this.
This is it's a contrived example. It spawns local and then it spawn blocking and then it spawn again within the. There's no need to spawn. There's no need. Anything beyond that local block on is pointless inside there. See, like just to remove all of that and put our code there.
Okay, I will just comment that. But also, we also need this cell.
No, that's after. That's called synchronously.
Okay. So.
And we need to keep result needs to be what block on returns.
Oh, okay. So okay. So like this. And
it's only lines 47 to
47. Okay.
47 to 50 that need to be inside the block on. We don't do this handle spawn.
Okay, got it. We just need to return this.
That's implicit.
Okay.
No, actually, you can't return. It's not a function. It's not a closure. It's an async block.
Okay. Okay. Yes. That makes sense. So we'll see if that works. Oh, it's having an error. If import refers.
We're not even. Oh yeah, that's Tokyo task.
Okay. RT, it's our handle.
Well, does it take a handle or does it take a runtime?
I think it takes a runtime.
You just point at block on.
Oh, let me see. Because I'm using the local. Let's try something. Do I have some?
Point at block on. Point at it to see the docs. See what types it takes.
Yes. We don't. Okay, local block on. Let's see.
Just point at it. No, just point.
Oh, point.
Yeah,
like
point
this.
at it. Don't even click. Just point. Yeah. Actually, don't click. Click outside. Click somewhere else and now point at it. Yes.
Oh, okay, got it.
And then don't scroll down. Stay at the top. The signature. It takes ref self and RT is a runtime concrete, nothing else.
Yes.
And so you can't, and so that's pretty much what I said we're going to have to do, right? We're going to have multiple runtimes.
Or get a current runtime somehow.
No, because well, you said you want to see it panic, so sure.
Yes.
You can do Tokyo runtime current. Try that.
Okay. Oh,
now
I'll just
remove that guard.
There's no. Okay, we don't need a guard. The current. I don't think we have a current function. No, go back. New. Yes.
Right. There's no such thing, right? Only handle you can do current, right?
Yeah. We can try sim.
Just keep in mind
Mm.
that this is all within the context of an attempt to see it panic.
Yes.
So if the types prevent you
Yeah.
from doing something that would panic anyway, then the
That's
types
a
are
good-
doing their work.
Yes.
Are working
Yes.
perfectly.
So let's try using the handle block on.
Yep.
Block on self.
I remember trying that.
And it was panicking, right?
Yes.
Oh, I think that was the information that I didn't have. I didn't know it wasn't actually panicking. Okay, but I got my time. So we'll
Mob
keep
next.
trying doing this. Okay, mob next. Okay, so
What spawn. So we don't need the guard here. We have a handle and we use it to do what we want, but it's impossible because block on says it is called from within an asynchronous context such as inside Tokyo main. Okay.
yes.
So cargo test this.
Let's see, it's panicking.
Cannot start a runtime from within a runtime.
Yes.
This happens because a function like block on attempted to block on the current thread while thread is being used to drive asynchronous tasks. And this is in the app, line 46 browser spawn.
But there's something interesting that error message.
What is that?
Okay, this happens because the function like block on is attempted to block the current thread while the thread's being used to drive asynchronous tasks.
Yep.
Yes.
I think this is the panic we were warned about.
Attempted to block the current thread while using is a function attempted. Yeah. I think there. Yes. I think it should be like an easy way to do that, maybe, but
Let's try spawning an ad hoc runtime. See what happens.
okay, let's see.
So it'll be something like let runtime equals Tokyo runtime new so I want to go to main and do this Rust LSP spans macro. Let's see what happens here. There's new current thread builder, runtime builder, new current thread, enable all build. I don't know if we need enable all build local. This is for build local. Expect, and then you can call block on. So sorry. So spawn. Okay, so we have our block on here.
Mm-hmm.
Tokyo runtime builder.
Mm-hmm.
New current thread. Maybe it should be new multiple thread, because this thread is also already being used for one. So
Yes, yes.
but I don't
So
know
it
that
should
it's
be
wrong either. Let's try not enabling anything, and then we'll get maybe a runtime error.
Yes.
And then we do unwrap. No, build. Wait, what is it? Build local options, default, unwrap. And then we have a block on.
Okay.
So types align. Let's see what happens. Cannot start a runtime from within a runtime. This is a function like block on, and this is line 48, right?
Oh, same error.
Well, we forgot something. So we're trying to do multiple runtimes, and you cannot start a runtime. So we are explicitly told we cannot start a runtime. We can do multiple runtimes, but we cannot start a runtime from within a runtime. So we're going to have to remove this Tokyo main. Am I right?
Yes. Yes.
And then this main cannot be async.
Yes. And then but then we can do.
Wait, this is just for experimentation. That's not the real one. This is the real one.
Okay.
And then we're told that this is not async. Why are we told? Because we have an await here. So if this is the case, that's fine. We can do stood thread sleep park. I don't know. Blocks unless or until the current threads token is made available. Threads block build sleep duration max. Okay. Now we're going to have a problem with subscriptions. Because right, subscribe. But wait. If this subscribe is the thing that needs I think I got it. I think it just snapped in my mind.
What
and
is
you know
it?
what I'm going to do? I'm going to restore this, and so I don't have to next you the. Okay, I think you can rotate, and then I.
Okay. Okay, so mob start 7.
The place where we are trying to obtain a runtime is inside the closure given to subscribe.
Okay.
That is by definition inside a runtime, because subscriptions are called from within, from their spawn local.
Yes.
It's within that call. It's by definition within a runtime. So I think what is missing is what I've already read and I've disregarded as, no, that's not the solution. But actually it is probably the solution. And it's in the documentation. It's in the Rust RX Rust book. So it's not the docs that you can build; it's the docs that are on the web.
Ah, okay.
I read it and I said, no, that's not it. It's too. I don't know. It didn't click
Oh,
that would actually be the. Yes, but not this. The book. If you go to
the
I don't know,
book.
just search again and then don't choose this result.
Okay, the book.
Well, you see the fourth result.
Oh, it's here.
Yeah.
Okay.
Okay. Now go to 4.
Async interrupt.
Right. So there are a few different ways to interoperate with async.
Mm-hmm.
It's divided into future interoperability and
Mm-hmm.
stream interoperability and Tokio integration practice. Definitely not 2 because, well, I think we don't have a stream, like, right? We have as a future
Yes.
from the library, from the
Yes.
browser library.
Yes.
So let's look at future interoperability. There's from future and into future,
Yes.
right?
Yes. Oh, yes.
So there it is. Basically, this is it. We need to like flat map and use from future, something like that.
Yes. From future. Subscribe my future. Subscribe.
We can use local from future. You want to try it?
Okay, let's see it. So local from future, like this.
Actually, it'll be before the subscribe.
Before the sub. Oh, it's here. Okay.
It'll
like
be.
This. No.
I'm thinking whether it'll be before the delay or after. I think it'll be after the delay.
Okay.
So after the delay, we're going to do a flat map, I believe.
Flat map.
Let me see. Map each item into an inner observable. Merge the result. I don't maybe merge the result. I don't know why merge, but I think this is it.
Mm-hmm.
So, and give this a closure.
How do I do a closure?
Double pipe. The closure pipes are the parameter list.
Okay.
So inside the pipe, you add the. I think in this case it doesn't matter because we are disregarding the command.
Yes. So I
And
use like
now
this.
give it a body, or maybe we don't need a body. That doesn't matter. And then here you do local from future.
Okay.
And what you pass here is an async block, right? Async and a block. And you put our browser init
Okay.
inside there. But hold on just a moment. Okay. So to clear out the entire subscribe body.
Yes. Just delete it.
That's beyond.
Right?
No, that's beyond. Not the entire. We only need the sender. Yeah.
Yes.
Event sender, and now
then
subscribe does take a parameter, right?
Oh,
and it's the result.
yes. So I use like this. No.
Yeah. That was correct. What's the error? What's
There's
the
no
error?
error. Oh, wait a minute.
Did you save?
Let me see.
what's
Now
the
I
error?
see.
Can you do F8 instead of pointing at it?
F. F8. Oh, F8 like this.
Shift F8.
Okay.
F8 and Shift F8 is like next problem, previous problem. So it depends on where the caret is.
Oh, okay. Okay, got it.
The method subscribe exists for struct yada yada, but its straight bounds were not satisfied. Why not? The following trade bounds were not satisfied. I can't read this. Can you scroll to the right?
Oh, yes. Maybe we need a box.
Can you scroll all the way to the right? Okay, hold on.
Mob.
Observable type. Rotate.
Okay, so I will just close it, save it, map next. And then, okay. Stop
I
sharing.
think we're using the flat map wrong, maybe.
Yeah.
Or is it, maybe it's not flat map.
Or maybe we need to box something.
I don't think so. What are we getting here of a merge all of a map of a delay of something? Of a box of something. From future. Creates an observable. Flat map. Flat map. I think that's that. Up to. Flat map. Why wouldn't it be flat map? You see an example of flat map? It's flat map for sure. Look at this. You subscribe. This closure returns an observable. Right?
Yes, but maybe
an
the
observable.
type, there's something wrong with the type, maybe.
Subscribe exists for local context. Merge all of map, of delay, of box, of something, some bit straight bounds were not the following. Were not met the following. Okay, we have to read this way. Not observable type. Not satisfied. I'm pretty sure we're using from future wrong.
Yeah.
But this is async. No. Browser init. Oh wait. Map. Browser. I mean this I saw compile this code compiled without a problem, and a moment ago, right, when we had the panic.
Yeah.
And this doesn't seem like it's wrong. This is just the command that we're not using it. But then we cannot subscribe to it? Why not?
Yes, that's weird. I th- oh, I think we should look maybe at the documentation to see and code example to see if we are doing something wrong.
Consider using verbose to print the full. How do I cargo build, cargo check, verbose. Box dyn. Here's the full type, right? Merge all. Before that, there's a map. So this is flat map, right? Merge all and map. And this is the delay right before then. And this is what we got from the, I don't know, this is what the driver takes. And here there's the local context box, dyn core observable local box. It doesn't seem wrong. Can we do this with, if we just comment this out, right? And we say this doesn't return it, it's unit, okay? That
Okay,
still doesn't
I'm
work.
sorry. Yeah.
Right? This is a future. F must implement future. Let's see the example here. So from future ready, and you can subscribe to it. What do you know?
Yes. Yes.
Is this not possible with the
flat map?
With local? Is this only local from future?
Oh yeah, that's a good question.
No, but here local. That's the example, right? Local from future.
It's possible. Yes.
What is?
Maybe it's not flat map. Maybe it's another thing.
Well,
yeah, but it's
switch
using.
map?
Wait a minute. Wait. Let me think about it.
I think it's maybe switch map.
Yeah.
Map each item into an inner observable and switch to the latest one. The switch map. Oi.
I got rid of the error when I tried to do this.
But it's not you're not pilot.
Yes. Yes. But I got curious.
Whoa. What happened here? I don't know what happened. Browser spawn. Well, we didn't panic, right? So that's nice.
Yes.
But we also did not get this event, right?
I
think we made great progress understanding like that.
Yes.
Just read the docs and actually trust that they're telling you the truth.
Yes. So it's
I'll be back in a moment.
Okay, sorry. Okay. I'll wait for you, so.
I'm back.
Mm-hmm. Mm. I'll just do it mob start. No, I already got mob start, but
You
just
can
let
do
it
mob.
going.
You can do mob T7.
Okay.
That's only the timer operation.
Okay. So
save.
still got. Okay, thank you. So what next? We can try running the app, but you said that this event wasn't firing, right?
It wasn't reaching the app. Maybe it's not even wired to reach the app. Can we take a look inside the app?
The app, like this.
Above that? More? Okay. You see line 61?
Yes.
That's where we have a missing member in that array.
Oh, yeah, we need to, yes. We need to, is, okay, like, it's of the type process browsers like this?
Yes.
Just that?
And 71.
71. I don't know. What should I put on 71?
So it's a different field. It's probably something like
I don't know what is the field.
browser spawn driver events.
Browser spawn.
It's okay if you don't have completion. Just try type it. Okay. So if you don't have a completion, it's probably because the inputs struct does not have this field yet.
Oh yeah. It doesn't.
Add it.
Okay, just let me just. Okay. Wait a minute. So wait. Callbox observable. So, but this is
Browser spawn driver
like
event,
this.
not
Driver.
command.
Okay. Okay. Cannot find. Type alias if it's procedural mode.
No,
Oh, it's
I
here.
don't think it's a type alias. I think it should be imported from there.
Import crate like this.
Yep. Yes. Okay. That that variant is also missing.
Generate variant.
Variants, good, yeah.
Oh,
But
so it's
it needs a field.
like this.
That's right. And now the match would be you can use the auto fix. There we go. Browser spawn.
Just
Give it
like
a body.
that. Oh, okay.
Put a comment in the body so it doesn't remove your body. And let's run the tests.
Okay. How they do that?
Cargo test. Try the test. No capture. Wait, no capture. Yeah, no capture. Separator.
Hyphen.
Yes. Actually, the separator is before no capture.
Okay.
And now the something like page content is no. I think we want the test that says a browser is launched. Actually, I think it doesn't matter which one we run. Browser is launched. It'll be snake case.
Snake is underlined. I don't remember.
Yes. It's underscore.
Underline like that?
Yes. This will take a while, so let's rotate.
Okay.
Alrighty then.
Yes. Okay.
Sorry, did you next?
No.
Go ahead, do it.
Sorry.
No problem.
I forgot about it.
Did
Done.
you now? Okay.
Yes.
Okay. What am I looking at?
Mob.
Missing. Oh, there is a type error somewhere here. Okay. Seems like sometimes. But whoa, it works. Look,
Oh,
event
really?
browser spawn. We have a browser.
Okay.
We have a browser. We have a browser. Look at us. We have a browser here. There we go. See this?
Yes.
Okay, so the event itself is like it has so this needs to be pub.
Mm-hmm.
Okay, and now we can event results. Okay, and now we can do like what's the error handling here? I think we could panic. If we can't start a browser, we could panic. I don't know. What do you think? Let's do
at least for a while.
so let's do a let let's do a match on the result.
Mm-hmm.
And here we have a browser inside an RC mutex because it needs to be cloned.
Mm-hmm.
And here we have some error and we like Don't know what to do, so there's a to do there.
Mm-hmm.
And now we can do something like let actually we have methods on this. So browser lock unwrap. I think you probably want to mutate the state. I think we want to do more than to lock it. Yeah, we probably want to like into inner. Can we do that? Consumes the mutex, returning the underlying data. We could try.
Yeah.
So let browser equals unwrap. So now we have the actual browser. Look at that. Now can we do something like let's browser dot debugging address. Can we have that? Because the next thing we need to do is to do this. We need to instantiate this thing.
Yes.
State for testing in order to give the test suite this information. And this is one of them. This is the browser debugging address.
Oh, yes, yes.
The surf path and the surf port, I think, are already available in that scope. And the browser PID. So I think we can do this now.
Yeah. Yeah.
So this is so there's more like, where's the match? Match is here. Braces, let browser equals. Okay. I'm not, yeah. This is one way of doing it. And then if, okay, this state for testing mode. See this testing mode?
Yes.
So if std and, or just env std env var fetches variable key from current process, right? Var testing mode is okay. Something like let state for testing equals state for testing. Just make one and state for testing print something.
Okay. So let's see. No, start 7. So we have state for testing dots. So I think the first we need to fill this, right?
Well, syntactically, maybe you can call the method and then fill it in later.
Okay.
So that
which
yes.
Okay.
So look at the type in the same module. There should be the various methods. I don't see the method here in the completion. So just go to the module and see. impl. It should be an impl.
Impl.
No, stay there. Yeah, and like just find. Well, actually, it has serialized, right? But can you go to implementations, find implementations on it?
Oh, okay, like this. Oh,
Is that locations?
locations.
This is locations, right? I'm not sure what locations means. But you can do find
Yeah.
implementations specifically.
Yeah, let me see it. Find our implementations. State for testing. Oh. So here's testing.
Is
it
that an
creates-
implementation?
Yes, I think so.
Print, line 9.
Yes. Yes. But it's not actually. That's weird. It doesn't seem like to be an actual implementation because it creates over here and then
It creates
just,
one and prints it.
and then yes,
It's funny.
It's just you,
right? You should
yes.
create one, and then this will only print it, right? Like so change this print to take only ref self.
Have self. Okay, got it. Like have self like this.
Amp.
Oh, okay, got it. Amp like this.
Amp self. And it will return an anyhow. Will it even return anyhow result? So no, it will not return anything. In fact,
oh yeah,
it will
that
not return
makes sense.
anything. I think that's nonsense. I think we can unwrap because there's no reason that it'll fail to serialize.
Yes.
So instead of that context on line 20,
Oh yeah.
call unwrap.
Okay, unwrap. And this I'll use this.
Right.
Is this needed?
That's also
This
self.
debug. Okay.
And I think it should not be debug. I think it should be info.
Yes. Oh, I need to import. And then I can just delete that like this.
Yes. That's all.
Okay. So sit for testing,
And then you can call print.
Okay. Yeah.
If okay. Okay.
So we just need to fill this values.
Now 121. Remove the let. We want to actually, we have a let browser and yes, that's right. Sorry.
Cannot move out of an RC. It doesn't implement a copy trait.
We need some other additional method calls, something like into inner try something, but before the unwrap, maybe. So what is the order of this? This is an RC first, right? So try, I think it's try unwrap before the into inner.
Oh, okay. Try unwrap. Okay.
Because it's an RC first and then there's a mutex. So try unwrap or I don't know. You can check the docs for RC.
It doesn't have try unwrap.
Yeah. Check the docs for
Okay,
RC.
RC is
Stood.
okay.
It's
Like
just Rust.
standard.
Yes,
Okay.
just search Rust RC. And look at the on the left, the list of methods.
Into inner, into raw.
What's into inner? Okay. I don't think that this will work because it's not the only copy. It won't be the only. I don't think it'll be the only copy. It may or may not. That depends on the operators involved. But we can just clone the friggin' RC. We don't need to do all this. We can clone the RC. What did we do then? Instead of try and wrap, just keep the browser as is.
Mob.
Okay, I will save it and it's mob next.
How are you with time?
Oh yeah, I'm okay, and I can I can have some more minutes. And what about you?
Yeah, I'm excited because it's finally all this been solved and we can focus on the logic.
Yes.
It's a huge unblock
Yes.
for me.
Yes. Yes. So
Mob next. Did you?
okay, yes.
Okay. Huge unblock.
I think we can just try to put the values into the structure and see what happens.
Yes, yes. Okay, so serve path is probably in scope or something, like serve path clone. Not in scope, like inputs, serve path clone. Project root. Where's the serve path? Inputs. No, it's not finding inputs. Inputs, serve dir. Okay, I get it. Inputs, serve dir, path, not into path, path, stir, to stir, to stir unwrap, to path buff, to string. What's the problem? This is supposed to be a path buff. So let's not do this. Let's do path to path buff. That's one. Serve port is probably inputs. Serve port. But it's a server port. Well, then it needs to be a server port. You know what? It's too much. Let's just do 0. It's private. Well, this is, yeah. So we definitely need to, this to not be private. Okay, that's fine. I think. No, it's no longer private. You can snap out of it. something wrong. Okay, it did snap out. Browser debugging address. So browser, the lock, debug, unwrap, debugging address.
Mm-hmm.
That seems to be working. And browser PID. So let's do this extract. And this will be the browser log.
Mm-hmm.
Where log. Get it? No. This returns a result, huh?
Mm-hmm.
What do we do? Is it async? Well, thank God it's not async. Why though? Why is it a result? Oh, because if fail to obtain mutable reference to browser child, and then this can also have no ID.
Yes, assign it.
Okay, so we need to like figure this out somehow. Error handling for this,
Mm-hmm.
right? Gonna like match on this. PID, and then error something, right?
Mm-hmm.
Cannot mutate, make it mute. No errors.
Mm.
Test. Spawn a browser. Boom.
Mm-hmm.
State for testing.
Oh. Okay.
Good. From here, like, I don't even know why this test is not like why this test is hanging, because as soon as this happens,
Mm-hmm.
we're supposed to be golden, basically.
Yes.
The test to end is browser. Is it? Am I doing browser is launched? Or which test did I do? Page content is served. Oh, let's try browser
Served.
is launched. Browser launch.
Mm.
It passed.
Oh.
This is the first passing test since the rewrite into RX Rust.
Yes.
The way that it passes is that actually, like in reality, there's this method here, connect to browser, which means that
Mm-hmm.
the same library, Chromium Oxide, in the test suite,
Mm-hmm.
the same library that starts the browser and controls the browser in the implementation is used
Mm-hmm.
here in the test suite to connect to the browser instance that the test sub that the implementation spawned.
Mm-hmm.
So the test suite connects to that browser. And if it successfully connects to that browser, that means the test passed.
Mm-hmm.
So we confirmed that a browser was launched and we're able to connect to it.
Mm-hmm. Yes.
So that's brilliant. Like this will probably, I don't know, maybe this will also pass. But I think we should end it here.
Mm-hmm. Okay. Do you want to to keep going, to check the next test, or do you want to? Because we already got a lot of progress today. What do you want to do?
No, I don't know. It's 9 p.m. here. I should probably get what is what is an idiom? Pack up and go to bed.
Yes. Because and we can do the test, the other test like next week, because we got a lot of progress today. So yes.
Awesome work, Flavio.
Yes, we got it.